In this video, we are going to write a program to multiply two matrices given by user. As we are going to take matrices from the user, uh, it would be only at the execution time we would get to know the dimension of the matrices. As we don't know at the compilation time the size of the matrices that user is going to enter. That's why we cannot go for statically allocating the memory for storing these matrices. So we'll have to go for the dynamic allocation of the data structure in which we are going to hold matrices. So you would have to look at the dynamic allocation of the data structure, and the intuitive data structure for holding a matrix is a two-dimensional array, because matrix contains has rows and columns, as well as two-dimensional array has rows and columns. So the intuitive data structure to hold a matrix is nothing but a two-dimensional array. So first of all, we are going to see a dynamic allocation of a two-dimensional array. So let me take you to my notes. So a two-dimensional array can be considered as array of one-dimensional arrays. So if specifically if you see 3 cross 4 two-dimensional array, it can be considered as a collection of three one-dimensional arrays of size 4. So each of these three arrays are of size 4, right? So we'll have to, for dynamic allocation of this of an arrays of size say 3 cross 4, we'll have to allocate three one-dimensional arrays of size 4, and the addresses of this one-dimensional array can then be stored in a one-dimensional array of array of pointers. So this is in one-dimensional array, and naturally the size of this one-dimensional array would be equals to the number of rows of the array which we are going to allocate, right? So let us go ahead and write a function which would allocate a two-dimensional array of whatever dimension we want it to, and it would return us back the address of the two-dimensional array, right? So here the address of the two-dimensional array is shown as ARR, and it would be a double pointer. If we are going to store integer values in this array, then it would be an integer double pointer, because it would be storing the address of first element of this one-dimensional array of pointers. So it has to be a double pointer. So let us go ahead and write a function which would return us the address of the two-dimensional array which it has, which it dynamically allocates. So the function's return data type would be a integer double pointer if we are going to store. So in this example, we are going to store integers in the we are considering integer matrices. So the function's return data type would be integer double pointer, and let us call it as get 2D array, and it is going to take dimensions of the array that we wanted to allocate. So rows and columns. Fine. So the first thing that we want to allocate is instead of this one-dimensional array, first we want to allocate this one-dimensional array of pointers first, because after allocating it, then we are going to allocate this one-dimensional arrays, and of these arrays the addresses would be stored in the cells of this one-dimensional array of pointers. So first we are going to allocate this data structure, that is a one-dimensional array of pointers. Now we are going to use malloc function to do that, and for that we have included stdlib.h header file. We could have used malloc.h as well, but it is not recommended to use malloc.h because it is old version. stdlib.h is what you should go for. Now malloc is going to return a void pointer, and that would be typecasted and it would be stored in integer double pointer. So let me call this as arr. So this is the variable in which we are going to store the value or the pointer that malloc returns us, and malloc returns a void pointer, so you typecast it first. Now malloc takes the number of bytes which we wanted to allocate. So here number of bytes in this one dimensional array would be uh, it it would be equals to number of bytes taken for each integer pointer into number of rows of the two-dimensional array. So there are 3 cells and each cell is an integer pointer, so it would be equals to number of rows into, we would be using size of operator, and to that we would pass integer pointer. So the size of operator would give us as it has been applied over integer pointer, it would give us the number of bytes taken for integer pointer, and to that we are multiplying rows. So this is going to give us the full total size of the one-dimensional array of pointers. So with this we would be able to allocate a one-dimensional array of pointers of the required size. Now we are going to go ahead and allocate this one-dimensional array of integers, and the size of each of these arrays would be equals to number of columns of the two-dimensional array. And then after allocating this one-dimensional array, we are going to store its address to one of the ith cell. So ith array's address would be stored in ith cell of the one-dimensional array of pointers that we have already allocated. And as there are several such arrays to be allocated, so we are going to do it in a loop. So let me declare a loop variable first, and in a for loop which would iterate for as many times as there are rows. So we have started from 0, so I less than rows, I plus plus. So this loop is going to iterate for as many times as there are rows, and in each iteration we are going to allocate an array of size equals to columns. Right, so inside this what we are going to do is we are going to um, assign the address of the one-dimensional array to ith cell of the array that we have already declared, array of pointers that we have already declared. So this address of this is going to get allocated to ith cell, right? So arri is nothing but the ith cell of the one-dimensional array of pointers, and we'll typecast the void pointer to integer pointer first, and then we would allocate it to arri. So it is integer pointer because it is address of the one-dimensional array. And now to malloc we are going to pass the size of the memory block that we wanted to allocate. So the size of the memory block would be given by number of columns into number of bytes taken by each integer, which we are going to get by size of operator. So this would do the task of allocating this one-dimensional array of size columns, and then address of it is going to assign to ith cell of the one-dimensional array of pointers, and we are going to return the arr integer double pointer to the caller. So I'm going to define the prototype before the main function because that's the function in which it would be called. Fine, so we are done with with a location of a two-dimensional array. Now few more things that I want to write as functions before going ahead with writing the main logic of matrix multiplication. So one of the functions that I want to write is a function which, when given a two-dimensional array, it prints it on the console. It prints its elements on the console. So this function, let us call it as print matrix. Print matrix would take as parameter the matrix itself, or the address of the matrix, and then number of rows and number of columns. Let us not call it as matrix, let us call it as ARR, that stands for an array, two-dimensional array. And in this we are going to write a nested loop for printing each of the elements of the two-dimensional array. So we are going to write a nested loop, and this nested loops, the external loop of this, the outer loop of this nested loop is going to iterate for as many times as there are number of rows in the two-dimensional array, and the inner loop is going to iterate for as many times as there are number of columns. And the way we are going to print it on the console is all the elements of the rows would be printed on the single line, and the next row would be printed on the next line. So this is the statement that I would be using here: %d and then a space, comma, then arrij, where ijth index contains the element of the array, two-dimensional array. And this loop, this inner loop, is going to print all the elements of a row on the console, and then the next element, the next row, has to be printed on the next line. So after printing a row, I am going to print a new line character on the console, so that we get a line feed and the next line. And when the outer loop goes to the next iteration, the next line of the array gets printed on the next line. Fine, so this print matrix function is done, and we are going to use it from the main function. So I'll have to define its declare its prototype before the main function. Now the third function that we are going to write here is to read the elements of the matrix from the user, right? So this is not supposed to return anything to the caller function, so the return type would be void, and let me call it as read matrix. So still we are a little distance away from the actual function that we are going to write for matrix multiplication. Before that, we are writing some ancillary functions that would be useful for us to make this program modular and readable. So this read matrix is going to take the two-dimensional array in which we are going to read the elements and store the elements. So let us call it as ARR, and then also it is going to take the dimensions. So we would be writing a nested loop for reading the elements from the user, the way we have written for print matrix. So let me copy paste this nested loop here, and here we are going to prompt the user to enter element of the matrix, and we are going to scan it and store it in ith row and jth column of the two-dimensional array. ARR ampersand ARR IJ, that is address of ith row and jth column of the two-dimensional array. And before this for loop, let me prompt the user with this line: enter the elements of matrix. Let's get a backslash in here and backslash in here. So enter the elements of matrix. So read matrix is also done, and it is going to help us getting the elements from the user. I hope I have not made any typos here. So let me build it once. So I think it has built correctly, so at least I have not made any typos here. Now let me write the function that would accomplish the task of matrix multiplication. So before going ahead to write the function, let us first discuss the logic of it and the patterns those appear in matrix multiplication. So let me take you to the notes. So here is my notes. Let me make it full screen. Yeah. So let's say we have two matrices of size 2 cross 3. So the first matrix, let it be 2 cross 3, and the second matrix, so as in the picture we have 3 cross 4 matrix, and the results dimension would be nothing but 2 cross 4. So here if you see the result matrix, it is 2 cross 4. So this outer dimensions would be the actual dimension of the result that we get, and this inner dimensions, that is column of the first matrix, should be equals to the number of rows of the second matrix. Only then, if they are equal, only then the matrix multiplication would be done. Otherwise, if these two are not same, then the matrix multiplication cannot be done, because the matrices are not compatible for multiplication, right? So this will have to check before we go ahead with multiplication. We have to check the column of the first matrix and rows of the second matrix are same or not. If they are not, we are going to tell the user that the matrices are not compatible, and would exit from the program. Fine. Now let us see how each of these elements of the result matrix is calculated. So if we look at C11, it is A11 B11 plus A12 B21 plus A13 B31. So this is the expression with which the first element of the matrix is calculated. And here if you see a pattern, that the suffix of this resultant matrix element is C11, right? It is 11, and here in this expression, this two suffixes of A element and B element are same as this 11. So here in all the terms of this expression, you'd see this pattern, right? So we have 1 here, and we have a1, first suffix of a is 1 and second suffix of b is 1. And similarly c12, if you see, the first suffix of a is same as this, and second suffix of b is same as the second suffix of the resultant. So this is the pattern that we have identified, and it is obvious in all the expressions that we have shown on this notes, that the first suffix and second suffix of the resultant element is same as the input element first suffix of the A and second suffix of B, right? And what about this intermediate suffixes? So here this intermediate suffixes would always be same. So here we have 1 1, then 2 2, and 3 3, right? And they are incrementing starting from 1 up to 3. And the last term, so we are going up to 3, and this would be same as the common dimension that we have considered. So the common dimension is, that is, the column of the first matrix and row of second matrix would be same, and this is exactly the number that we would get at the terminating term of the expression. So it would start from 1 and it would go up to 3, that is equals to the common dimension. So this is the pattern you would get in any of the expressions of the resultant matrix element. So how many resultant matrix elements would be there? So resultant matrix elements would be equals to 2 cross 4. So there would be 2 cross 4 elements, that is the number of rows of the first matrix into number of uh, columns of the second matrix. So these many number of elements would be there. And now, so we would be writing a nested loop for this, in which the outer loop would run for a number of as many times as there are number of rows in the first matrix, and the inner loop would run for as many times as there are number of rows in the number of columns in the second matrix. And inside that we are going to calculate each element of the resultant matrix. Now for calculating each element of resultant matrix, we'll have to evaluate this full expression, right? So how many terms are there in this expression? There are as many terms as there are as the common dimension. So there are 3 terms here. For other cases it would be same as the common dimension. So this terms also would get evaluated in a separate loop, which would be nested within the other 2 loops that we have already discussed. So we would look at one by one. So first of all, let me create a a nested loop mm, that would let us calculate the elements of the resultant matrix. So let us go ahead and start writing the code, and then it would be clear. So this matrix multiplication is going to return nothing as such to the caller. Let us call it as multiply matrices, and it is going to take as pointer the address of the result two-dimensional array in which it is going to store the resultant matrix. And it is going to take the dimension it is going to take the two-dimensional arrays as well, the address of the two-dimensional array input matrices. Let us call it as matrix 1 and matrix 2. So these are the 2 input matrices that it is supposed to multiply and then store the results in the result two-dimensional array. So let us delete this. We would not be needing this parameter. Internally we would allocate by using this this function that we have already declared, get two-dimensional array, we would use this inside this multiply matrices to get the resultant matrix, get the two-dimensional array in which we are going to store the resultant matrix. Now matrix 1, matrix 2 would be the parameters, and now the dimension of the first matrix is int row 1, and then column of the first matrix and rows of the second matrix are going to be same. So let us call it as common dimension, right? So instead of taking two separate parameters which are going to be same, we are taking a single parameter and naming it as common dimension, and that would give us the number of rows and number of columns of first matrix and number of rows in the second matrix. And then we are going to take number of columns of the second matrix and we would call it as column 2. Now we'll have to get a result matrix, a two-dimensional array in which we are going to store the result matrix, and we would be using this get 2D array, and the dimension of the resultant matrix would be what? That would be equals to number of rows of the first matrix, that is given by row 1, and number of into number of columns of the second matrix, and this is given by column 2, right? So this is what we are getting as parameter from the column row 1 and column 2. So the dimension of the resultant matrix would be that. So we are getting the pointer of this two-dimensional array and we are storing it in result. Now as I said, we would be writing a nested loop for evaluating each element of the resultant matrix. So it would start from 0 and we would go up to 1 less than number of rows in the resultant matrix. So number of rows in the resultant matrix is equals to row 1. So as we are starting from 0, we would be going up to 1 less than row 1. I plus plus and again for loop which should start from 0, and the number of columns in the resultant matrix would be equals to call 2, and inside this we are going to evaluate the ijth element of this resultant matrix. So ijth element, so result ij. So let me take you back to my notes. So here each of these elements are going to be evaluated first, and then we are going to accumulate it in the result ijth element. So result ijth element, this element represents an element of the resultant matrix, right? So to evaluate this full expression, we are not getting this we cannot evaluate it at one go. We'll have to evaluate each term at one time and then accumulate it in ijth element of resultant matrix. And because there are three terms, that is as many terms as there are common as the common dimension is, so we are going to take another loop to accumulate each term in each iteration of this loop to the ijth element of resultant matrix. So we would initialize this resultant matrix, ijth element of this resultant matrix, to 0, and then we are going to take a loop that is going to iterate for as many times as the value of common dimension. So let us take another variable and name it as k, and we would initialize it from 0, and as it is going to iterate equals to the value of common dimension, so k less than common dimension and k plus plus. And in each iteration we are going to evaluate one of the terms of this expression, and then we are going to accumulate it in the ijth element of the resultant matrix, right? So the accumulation statement would look like this. So ijth element is equals to current value of ijth element of the resultant matrix plus matrix 1. So matrix 1, so we have already discussed that the first dimension is same as first dimension of resultant matrix. Matrix 1's first dimension is same as first dimension of resultant matrix, and matrix 2's second dimension is same as second dimension of resultant matrix. So see here how would this be converted into implementation. As matrix 1's first dimension is same as I, and we'll have to determine the second dimension multiplied by second matrices. So second matrices second dimension is same as second dimension of resultant matrix, that is J. And what is we are going to fill in here is nothing but k, because k is the dimension, k is the variable which is iterating from 0 1 and up to and going up to common dimension. So that is what we want here. This common dimension is starting from 1, it is going up to 3. So as we are starting from 0, we will go up to 1 less than the common dimension. So k is the variable that we are going to use here. So with this, if I have not committed any typos, so this matrix multiply matrices is done. At the end we are going to return to the caller the address of the resultant two-dimensional array in which we have hold the resultant matrix. So we are going to call it from the main method, so I'll have to put the prototype here before the main function. Now we are going to call this functions from the main function. So before we can allocate this arrays for holding this matrices, we'll have to ask the user about the dimensions of this matrices. So we prompt the user, enter dimension of matrix 1, enter dimension of matrix 1, and declare few variables to hold these dimensions. Int row 1 column 1 to hold the dimension of matrix 1, and row 2 and column 2 to hold the dimensions of the matrix 2. Now I'll be using scanf function to get these dimensions and store it in these variables that I declared. Row 1 and address of column 1, and the same thing would be repeated for matrix 2. And earlier, as I said, if this matrices are not compatible, which we can check by comparing the values of column 1 and row 2, if they are not same, then the matrix multiplication cannot be done. So we are going to check if column 1 is not equals to row 2, then these matrices are incompatible. So prompt would just display the error to the user. The matrices are incompatible, and we are going to exit. For that we are going to use this exit function, and if they are compatible, then we are going to use this read matrix function. And before that, so we are going to use this read matrix function to read the elements. So read matrix, and yeah, so read matrix is going to take the address of the two-dimensional array. So before it, we'll have to allocate the two-dimensional array for it. So the two-dimensional array address has to be stored in double pointer, so we'd call it as matrix 1 comma matrix 2 matrix 1 equals to matrix 1 equals to get 2D array, and the dimension of the first matrix is given by row 1 comma column 1, and then this is going to get passed in the read matrix. Again we'll have to pass row 1 and column 1, row 1 and column 1. So with this we have accomplished the task of allocating a two-dimensional array and then reading the matrix 1. Same for the matrix 2, same for matrix 2. Let me check read matrix 1, enter the elements of matrix. Okay, now one by one, before using multiply matrix, I want to print the elements of the input matrices on the console. So I'll be using print matrix function that we have already defined, and it takes as parameter the pointer of the matrix that we want to print, matrix 1, and dimensions of it, column 1. So before that I want to print matrix 1. Matrix 1 backslash n. Same for the matrix 2. I want to print the matrix 2 on the console. So matrix 2 would be printed on the console and the pointer would be sent to print matrix. Now one more thing is the resultant matrix would be returned by the multiply matrix function. So now I'm going to call the multiply matrices function. In that, matrix 1's address would be passed and matrix 2's address would be passed, and then number of rows of the first matrix, and common dimension. In place of common dimension, either the column 1 or row 2 can be passed. So let me pass a column 1 because they are same. and then row 2 to be passed. So it is going to return the pointer of the resultant matrix that we are going to collect in this two-dimensional pointer. So here I've missed one thing, asterisk 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 asterisk. Fine. So these are two-dimensional pointers, and in a single line if you want to declare it, then the asterisk asterisk has to be repeated. So after this result is there with us, we are going to print it on the console. So I'll repeat these lines, and this is the benefit of having this print matrix function. We didn't have to repeat the logic 3 times. We are using it as many times as we need, and the code is still very much readable. So this print matrix function, we are going to pass this result two-dimensional pointer, and hopefully I have not committed, yes I have committed some typos here. So what does it say? It says multiply matrix in function, return value within function, returning void. Multiply matrices is returning void. No, it has to return a double pointer. So committed a mistake over there. Multiply matrices is supposed to return me the um, pointer to the resultant two-dimensional array. Enter dimension of matrix 1, let's say 2 cross 3. Matrix 2, let's say it's 3 cross 2. Enter the elements of matrix, so it is taking the input for matrix 1. So we would give some small elements here so that we can verify it easily. Enter element. Now enter the elements of matrix, so it is taking input for the second matrix. So matrix 1 and matrix 2, now it has given some error, so we'll debug it. Never mind, this would keep on happening. Matrix 1, matrix 2, matrix 1, matrix 2, read matrix. So read matrix, matrix 1. So here, because I've copy pasted it, there crept in some bugs which are very typical about the copy paste code. So I had to pass here row 2 column 2, row 2 column 2 here, right? So again there is too many of copy paste errors here. Hope we have rectified it. Print matrix result row 1 and column 2. So there are too many of these that I've committed. So row 2 column 1, row 1 column 2. Now let us build it. Hope this time it would work fine. Enter dimension of matrix 2. Let it be 3 cross 2, 3 cross 2. Enter the elements. So it would ask for 6 elements in total. Again it is 3 cross 2, so again 6 element would be asked. Now the result is printed as 712 in the first row, 915 in the second row. So let us check one of the elements. 2 into 2 is 4, 1 into 1, 4 plus 1 is 5, 2 into 1. 5 plus 2 is 7, so 7 is correct. Now let us check this element. 2 into 3 is 6, plus 1 into 2 is 2, 8. 8 plus 2 into 2, 4, that is 12. So this is also coming out to be correct. So like that, all other elements would be correct definitely. So we are done with this program, and we have written a modular program with a little bit of typos that we committed earlier. We have corrected it in the course, and now we have a program which is working and running fine. And you might have seen that I have used several functions to create a modular program. And the beauty of modular program is that it is very much readable. So in the main function, if you see, just by getting to see the name of the functions, you'd get to know that what am I doing coarsely, right? So it would make the program readable, and also the maintenance of such a program is easier. So go for modular programming whenever and wherever you find it to be correct. So hope you have enjoyed this video session, and likewise I am going to upload many such basic programs which would make you upgrade your programming skills. So keep watching my videos. Thanks for watching.